Today I will be discussing today's code forces round, div 1 plus div 2 and problem D matrix cascade. Okay, so there is a matrix given of size n cross n which consists of zeros and 1 only, and the rows are numbered from 1 to n and from top to bottom, and columns as usual, and columns are numbered from 1 to n from the left to right. Okay, so Aquamoon wants to turn all elements of the matrix to zero. Basically, our goal is to convert every element of the matrix to zero. And for this, obviously, we would have to perform the operation. And in the operation description, we have been given that in the description we have been given that uh, we have to select a cell, arbitrary cell I comma j, then invert the elements in I comma j. So basically, if there is a matrix and we have to select I comma j, okay, I comma j, and also invert all elements in the cell x comma y. So suppose if we are selecting I comma j, I comma j, then also all the cells having coordinate x comma y such that x should be greater than I. Just observe here, x is greater than I means the upcoming rows. It should not be the previous rows. It should be the rows greater than I, and such that these conditions satisfy means all the coordinates, all the cells having the coordinates which satisfy this condition means x minus I is greater than equals to mod of y minus j, then we would have to invert them also. So to invert a value means to change to its 0 changes to 1 and 1 changes to 0. It's quite obvious as usual. Now help Aquamoon determine the minimum number of steps she needs to perform to turn all elements. So basically, we have to return the minimum number of steps so that all the elements will of the matrix would changes to zeros. Okay. So let's talk about the constraint. You can see the constraint is 10 to the power 3 into 10 to the power 3, and sum of n square would not does not exist 9 to 10 to the power 6. So let's first discuss the first example. Okay, so the first example is n is equals to 5, then we have been given 0 0 1 0 0, and then I can say 0 1 1 1 0, then 1 1 1 1. Yeah, so I can say that now, uh, suppose I am just, since these all are zero, so there is no need to change. So this is the one, this is the one. I can say, suppose I am following the one based indexing 1 2 3 4 5 1 2 3 4 5. Okay, so what is the coordinate of this 1 comma 3? Obviously, so if I am changing this to 0, which I have to change. So if I am changing this to 0, so all the coordinates which would satisfy all the cells having coordinate x comma y which would satisfy x minus let me see, x minus I, yeah, x minus I greater than or equals to mod of y minus j. All the cells which would satisfy this condition, I would also have to just invert them. So let's see which are the cells which would satisfy this condition. So I can say that let's observe first. Now, since I have to x should be greater than I, it has been clearly stated that the upcoming rows should be considered. So let's just consider this row. Okay. So 2 comma 1, then 2 comma 2. I am considering x comma. I am considering for the cells x comma y. Okay. Because I comma j is fixed. I 1 comma 3 means I am inverting. I have decided that I will invert the cell 1 comma 3. Okay, 2 comma 3 2 comma 4 and 2 comma 5. Let's just see which are the cells which would satisfy this given condition. 2 comma 1, for the 2 comma 1 you can see that 2 minus 1, 1 is not greater than equals to 3 minus 1, mod of 3 minus 1, it should be 2. So it is wrong. So yeah, this cell is not gonna affected if I just invert this. Let's just see for this. It would be 1 greater than equals to 1. Yeah, it is satisfying. Means what, 2 minus 1 is greater than equals to mod of 3 minus 2. Similarly for this also, 1 is greater than equals to 0. Yeah, this is also satisfying. And now 2 comma 4, 2 comma 4, you can see 1 is greater than equals to 4 minus 3, 1. Yeah, obviously it is also satisfying. But now you can see here 1 is greater than equals to 2, it would not satisfy. Okay, so you can see that only these three cells would satisfy this condition. Let's see further. Let's see further whether all other cells are also satisfying or not. Let's this time see for the third row. Okay, third row, I am considering third row. So x comma y, so 3 comma 1, 3 comma 2, 3 comma 3, 3 comma 4, and 3 comma 5. So 3 minus 1, 2 is greater than equals to 3 minus 1. Obviously, it would satisfy. 3 minus 3 minus 1, 2 is greater than equals to 1. Yeah, it would also satisfy. 3 comma 2 2 is greater than equals to 0. Yeah, it is also satisfying. Similarly, this also will satisfy, and this also will satisfy. So now you should be able to observe one thing, that if I am considering this, then all the diagonal elements would satisfy. All the diagonal elements would satisfy. Means this is the range for the row. The left diagonal, suppose I am going this way, then this diagonal and this diagonal, and all the cells in between them also would satisfy this condition. So this is one of the main observation. And now after this, you can see the row has been what I can say is going out of bounds. So this will be the area for this. This will be the cells which would be affected after inverting this row, this cell. Okay. So now what I can say that these. Now let's come back to the question. Okay. So these two are zero, so there is no need of inverting them. These again, these two are also zero, so there is no need to invert them. This was one, so I am just inverting it to zero, and now you can see that all the other ones which need to be converted to zero would lie in the area of this 1 comma 3. Obviously, so all I can just invert them. Okay. So you can say that now my job is done. So only one operation would be required to invert this, and all the other cells which having the value 1 would get inverted. So this was the problem, we can say. Now let's discuss the other also, second test case. So it is 3, then 1 0 0, then 1 1 0, and 1 1 0. So uh, just I have discussed that if I consider this cell, then all the diagonal elements, means the all these cells between the diagonals would get covered in that. So suppose here we need to convert this. And also you should observe why I am just starting from the uh, first row. Okay, means the starting rows. Why not I am starting from this last rows? Because we have been given that x should be greater than I. So if I just does it make sense that I will just start from the here only, and now if I just move on to the above, then again I will have to apply operations, because obviously if I just apply the operations in the lower rows, so my upper rows would get unaffected. But there is a benefit, if I just start my operation from the upper rows, then also the lower rows would get affected because of this property. Okay, that's why always I will start from the first row. Now So this one need to be inverted. So you can say that if I just invert this one, so these will be the rows, these will be the cells which would also get inverted. So yeah, I can invert this to 0 0 0 0, and now you can see that this one, this 0 have become 1. Okay, so obviously I would have to explicitly also convert this, and now if I convert this, there is no further rows to be affected, so only two operations would be required. Now let's move on to the third. Okay, this is very so this was the test case. This is a very large test case, and also the this test case would be enough to explain my approach. Okay, so now you can say that I will again start from the first row, and now these three ones should be inverted. So I can say that one thing you should be able to observe till now, that if I am just modifying the if I am just inverting the upper rows, I am performing operation on operations on top rows would affect the lower rows also. Means the cell which lie in their impact would also get inverted. Okay, so 1 2 3 4 5 6, then 1 2 3 4 5 6. So if I just invert this, suppose I am inverting this to 0, so obviously these will be the diagonal, these will be the diagonal, and this, and now again this, yeah, up till this. So all the rows would get affected. So suppose if I just count, so now I can say that this again, this one would become 0, then this also becomes 0, this also becomes 0, 1 0 0 0, or I can say 1 1 1 1 1, then 0 0 0 1 0, and then 1, I can say, have I done anything wrong, 5 comma 6, and then 1 comma 2, 4 is greater than equals to 4, yeah, this will also come under. So 1, and then 1 1 0 0 0 1, so this would get affected. Now suppose if I just apply the same operation for this also, because I would also have to convert that, so it would become 0 here, it would become 0 here. So you can see that all the cells which would lie in all of these three cells, in the impact of these three cells, would get inverted. So only thing is required to check the parity of the cells, because suppose I this the value is 1, the value was 1, and now I applied three operations on it, again it will become 1. Odd operation if I perform on one, then it would become 1, and if I just perform even operations on 1, then it would become 0. Sorry, it would become 1. uh, Sorry, it would become 0 if I just perform odd operation to 1, then it would become 0, and if I perform even operation on 1, it again become 1 1 2 0, then it would become 1. Yeah, so Similarly for 0, if I just perform odd operations, then it will become 1, and even operation, I can say it will remain 0. So I can say that what I will do is that now I am just moving on to my solution part. I will What I will do is that now I will start from the upper rows. I will start from the upper rows, and now if there is a requirement, if there is requirement to invert that cell, I will change that. I will change that, and how I will decide? How I will decide that there is a requirement? How to decide there is a requirement to invert? So I can say that using this only. Suppose if it is 1, and now I have applied even number of operation, means till now the impact, means I can say that till now there was even number of inversion to that because of the impacts of the cells which I have inverted till now. Okay, so I can say that if there is 1 and I have till now performed even number of inversion to that, so obviously there is a requirement to invert it. There is a requirement to invert it. Also, if it is 0 and I till now I have performed odd number of inversions, so obviously there is a requirement. So now I guess you should be clear with the approach. Okay, so now how to decide the number of inversions till now I have performed on that cell. Okay, so now I am going to discuss that only. So suppose I am performing the operation on 1 comma 2. Okay, 1 comma 2. Let's move on to the next. So if I just perform operation on a cell, okay, so I can say that, yeah, after going to the next cell, I will carry a 1, means I can say that these were the diagonal elements. I will just take care of just take care of the next row each time. This will be enough. So I can say that now uh, I am performing the operation here 1, and also these I have to perform this cell will also lie in the impact. Okay, and all the cells in between these two will be in the impact. So I would just discuss a concept here, then you will be more clear with my approach. Suppose now I want to say that I just want to add 1 to all the cells, to all the elements of an array between index 1 comma 4, let's suppose. Okay, so what I will do is that I can say that if I just make a 1 here and do here a minus 1, and if I just perform a prefix, why I am just using this, I will just say that because of means saving our time, means time complexity, to reduce the to make the time complexity optimal. Okay, so now if I just take the prefix of this, I can say that all would be 1, and now it would become 0. So I can say that all the elements in between 1 comma 4 have been added to 1. Okay, so that's also I will apply here. So suppose if this value is 1 now, means when I was at this cell, I would just make here 1 and make here 1. Okay, so I will say it as right carry, means carry in the right, and I will say it as carry in left. Carry in left means each time when I am in just inverting a cell value, then I will also carry uh, the ones to the further cells. Okay, so now when I will just arrive at their row 2, I can say that I will just make here 1. Okay, I will say that yeah, it is 1. So obviously I will just make here 1, and I will also see that here is 1. So I will just make the next column, then the cell next to this column as -1, according to this concept. Because here you see that if I just wanted the uh, cell no, elements between 1 comma 4 to be added by 1, so what I have done, I just make the element 1 plus 1 and element 5 means 4 plus 1 as -1, because I don't want to continue the contribution of 1 after the index 4. Okay, so that's also I am just doing here. Okay, I hope the my solution is clear to you. So if here it was 1, so I would just make the next column 2 as -1. Now I can say that if I just perform the prefix, it all would become 1, and now it would become 0. And now you can see that these three were the cells only which was getting affected if I just perform the operation inversion operation on this cell. Okay, if I just perform the inversion operation on this cell, these only the three cells which would get affected. And now I will just repeat this operation every time I am going to the row. So now I am going to summarize it. Also, I will not just stop here. When I am just making here 1, I will also just I will also make here 1, means I will just carry the 1 here to the next row also. Similarly for that also, similarly for the third row also, I will just make here 1. Okay, so that when I just arrive at the third row, I will again perform this operation, the same operation again. So let me just summarize it. So now approach I am discussing. Each time if I am in a row, each time I will perform a inversion operation. I will carry it to the next rows also. And how I will carry, I have already discussed in the previous slide. You can see I will just make the next column, means if I am just suppose I comma j here, then what I will do is that I plus 1, because it will be the next row, and j minus 1 for the left part, and for the right part I will just make I plus 1 comma j plus 1. Okay, so and how I will carry in I will perform an inversion operation whenever required, when required, and I will carry it to the next rows. And requirement, when the requirement is, now you should be able to feel that why there is a requirement to just uh, when there would be requirement, because if I performing operation on a cell, obviously the other cells below that which lies in the impact of that cell would obviously get inverted. Okay, so how to check the requirement I have already discussed. If it is a 1 and till now I have performed even number of operation, so it would remain 1. So obviously there would be a requirement, there would be a requirement. Similarly, for the 0, if I have performed odd number of operations, it would have become 1. So here also there would be requirement. So I hope the approach is clear to you. And now once I code it, you would be more clear with the solution. Okay. So I have already taken the inputs. I am following the one based indexing because I would also have to perform the prefix. So there would be no requirement of the means checking for index greater than zero or not. Okay, that you will feel once I code it. Sorry, it will be cat. Uh, I forgot to take an. Yeah, that's it. So now I will just take a index. Means I am taking index. Index is the first row from where I have to perform operation. So basically, from which row you will start the operation, performing operation. Obviously, the row having one. So, and if suppose if there is no row having one, so obviously you would have to not perform any operation. For int I is equals to one, I less than n, I plus plus. I can say okay. Rule okay is equals to false each time, and now I will check whether there exists any one in this row or not. If aij equals to 1, then okay is equals to true, I can say. Sorry, uh, index would become I, and then I just break it. Okay, and I will just also make it as true. If okay, then I will again break because I have got the row. Now if index is equals to -1, what it does indicate means I have not got any one in the matrix. So in that case I would just print 0 and I would continue. Now I would keep a count variable for restoring my answer. Now which I have now I am going to the part where I have discussed the left carry and the right carry. So I will, for that I will just maintain left carry n plus 2 comma vector of n plus 2, and right carry n plus 2 comma vector of n plus 2. And also I would require a prefix, which I have already discussed that I would also have to maintain the prefix. I would also have to maintain the prefix. Now for int I is equals to 1, I less than equals to n. If I is not is equals to index means if this is the not the first, if this is not the first row. Okay, so why I am saying so, because I do not actually requires that to be means this, since this is the first row, so I actually did not require the prefix. That's why I have written so. Again, it depends here on implementation, because the only matters is the approach. You can code it on yourself in another way. That's not an issue. Now, what I will say is that if there exists a left carry, which I have discussed, if there is a left carry, so what I have discussed, if left carry exists, then I would say that prefix of ij plus equals to left carry. Means I have to maintain the carry also. Means the previous carry. Okay, and then carry left I plus 1 j. I would just also pass this to the next rows, which I have said that I will also pass this to next rows. I am just doing here max comma 1 comma j minus 1 because it may happen that the j minus 1 would be less than 0. So that may go out of bound. So carry left, what I have done wrong, carry left, oh sorry, left carry it was. Left carry equals to plus equals to left carry I comma j. Now I will also perform this for the, if there exists a left carry on this cell, then only I will perform this. Similarly for the right carry, if there exists a right carry on this cell from the previous cells, then obviously I would have to uh, perform this. And I can say that here I will just require prefix of I j plus 1 minus equals to carry right I comma j. If there exists means I am here in this section I am performing this operation. uh, yeah, I am performing this operation. Yeah, this part means maintaining the ones means the contribution in that row. Okay, so carry right minus is equals to carry right ij. Now carry right I plus 1 j, I will have to pass it to the next rows. So minimum of n comma j plus 1 plus equals to carry right, sorry it should be carry right, what I am doing, right carry. Yeah, it is fine. Now I will just perform the prefix for int I is, for j is equals to 1, j less than equals to n, j plus plus. So prefix of I j I can say plus equals to prefix of I minus 1 j. Now for this row I will just perform the main operation. J is equals to 1. I have means I have till now I just have maintained the carry which I have to take care of in this row and the next for the next row. Okay, now I will perform the operation on this current row, which is like the requirement for the requirement. Int num is equals to prefix of ij. So based on the prefix, what is the prefix? Means the number of operations performed on this cell till now. Means prefix of ij denotes the number of inversions performed on this cell till now. Okay. So when did I have said that there is a requirement? There will be requirement. Suppose if num modulo equals to 0 and aij is already 0, so there would not be requirement to perform the operation. So in that case I would just perform continue, means I will just continue. If num is uh, means I have just performed odd number of operation and aij equals to 1, So in that case also I would not be required to perform the operation. Why? Because since it was already 1 and I am performing odd number of operations, so it would become 0. It would have been become 0, so there is no need to perform the operations. So if these two are not the cases, so obviously I would have to perform the operation. And for performing operation, you know that just I would have to maintain the carry, and I will, for that, since I am performing the operation, I would just do count plus plus, and also I would have to just pass this carry to the next rows. Okay, 1 comma j minus 1. See, I am performing max of I comma j minus 1 just for the sake of means out of bound conditions, just checking for that. Okay, so yeah, left carry would increase by 1, and also the right carry for the next row, I plus 1 comma minimum of n comma j plus 1 would also increase. So that's all about the code part. Let's just run it. See out count. Okay, prefix of max of n plus 1, minimum of should be minimum of n plus 1. So it had failed somewhere. Let's see where it is, why it is failing. uh, so I have taken the input correctly, then I have taken, if Aij is equals to 1, then index is equals to I, okay is equals to true, break. So okay, then index is equals to minus 1, then 0, then count is equals to 0. I have taken left carry, then prefix, it is okay till now. Then I is equals to 1, I less than equals to n, I plus plus, I is not is equals to index, then I would just perform this operation. Left carry ij, if left carry ij, then prefix plus equals to carry of okay, left carry I plus 1, 1 comma j minus 1 plus equals to carry left ij, okay it is also right. Then left carry n plus 1 comma j plus 1 minus equals to carry left I, then it is also right, it is also correct. Then prefix of I minus 1, oh sorry, it should be I comma j minus 1, no, I comma j minus 1. Let's just run it. You can see it has been passed. So I will just provide this code in the comment section. Thanks for watching.